Hello students, how are you? I hope you all must be fine. I'm Mohammed Faiz, biochemistry mentor, and I'm back here with the fifth part of the chapter, is matter around a sphere. So, if you have not watched the last 4 parts, you should watch it. I will attach the link in the description box. So let's start our today's video. In this video, we will discuss about colloids and also about suspension. So students, you are already knowing that if you will dissolve some sugar or salt in water, then you will get a homogeneous mixture in which the particle size is less than 1 nanometer, and that is called solution. But what about some other substances like blood, like milk, toothpaste, jelly, butter, cream, etc. What about these substances? In which category these substances fall? So actually these substances are called colloids. These substances are called colloids. So heterogeneous mixture, they are classified into 2 categories. First one is colloid and the other one is suspension. So what is exactly a colloid is? So let's see its definition. So colloids, they are heterogeneous mixture. First of all, they are heterogeneous mixture. So what is colloids? They are heterogeneous mixture in which the particles having size 1 nanometer to 1000 nanometer are dispersed in the continuous medium. In simple words, we can say that colloids, they are the heterogeneous mixture in which the size of particles are between 1 nanometer to 1000 nanometer, and these particles are dispersed into the continuous medium, and that continuous medium in which these particles are dispersed, they are known as dispersion medium. So colloids has 2 components. Let me make it very simple. So just like in solution, we have 2 components. One of the component is called solute, which was present in less amount. Similarly, in colloid also we have 2 components. One of the component is called dispersion medium and the other component is called dispersed phase. One of the component is called dispersed phase and the other is called dispersion medium. So just like we have solute in solution, which is present in less amount, similarly we have dispersed phase in a colloid, which is present in less amount. Just like solvent in a solution is present in more amount, similarly the dispersion medium in a colloid is present in more amount. So what is dispersed phase? So actually dispersed phase are the particles having size 1 nanometer to 1000 nanometer, and it is dispersed. Where it is dispersed? Into the dispersion medium. So what is dispersion medium? It is a continuous medium. It is present in large amount, and in the dispersion medium the dispersed phase are dispersed. They are mixed. So it is very simple. Just like in solution we have solute and solvent, similarly in a colloid we have dispersed phase less amount में or dispersion medium ज़्यादा amount में. I hope it is clear to you. Now you know there are some examples like milk, butter, toothpaste, jelly, etc. They are the example of colloids. Now you know colloids, they are also known as salts. Salts, SOLS, and in some books you will also get colloids. They are also called colloidal solution. Why they are called colloidal solution? You know, colloids are actually heterogeneous mixture. They are actually heterogeneous mixture, but they looks like homogeneous. They appears to be homogeneous. वो लगेगा कि ये homogeneous ही है, but exactly वो होता कैसा है? Heterogeneous. ठीक है? But वो लगेगा कैसा? ये homogeneous है. क्यों? क्योंकि ये भी स्टेबल है. हमारे सॉल्यूशंस जो थे they were stable. Similarly, the colloids, they are also very stable. Okay? So colloids, they are heterogeneous mixture, but they appears to be homogeneous. Now you know, on the basis of the dispersion medium, there are some common categories of colloids. Just like if the dispersion medium is water, then the type of colloid is called hydrosol. Similarly, if the dispersion medium is alcohol, then the type of colloid is called alkosol. Alkosol. If the dispersion medium is benzene, then the type of colloid is called benzosol. Benzene se benzosol. And if the dispersion medium are gases, then the type of colloid is called aerosol. So hydrosol, hydro means water, alcohol, alco कहाँ से आया? Alcohol से, benzosol कहाँ से आया? Benzene से, and aerosol कहाँ से आया? from the gas. Air means gas. So these were the some common types of colloids. But now we will discuss about the 8 major classification of colloid on the basis of dispersed phase and dispersion medium. Yes, on the basis of the type of dispersed phase, whether it is solid, liquid or gas, and on the basis of types of dispersion medium also, we have classified the colloids into 8 types. As you can see here in the table, I have classified the colloids on the basis of the state of dispersed phase and the dispersion medium. So these are the 8 different types of colloid. The first one, where the dispersed phase is solid and the dispersion medium is also solid. So this type of colloid is called solid sol. Examples are colored gemstones which we used to wear in our fingers. Second is where the dispersed phase is solid but the dispersion medium is liquid, and this type of colloid is known as sol. Examples are toothpaste, mud. Mud में you can think mud में क्या होता है? Some solid particles are dispersed in liquid. The third one, here the dispersed phase is solid and the dispersion medium is gas. Solid dispersed in gas. Example is solid aerosol. Okay, this is called solid aerosol. Examples are smoke and dust. The fourth one, where the dispersed phase is liquid and the dispersion medium is solid. So liquid dispersed in solid, and this type of colloid is called gel. Examples are butter, cheese, etc. Next is the dispersed phase is liquid but the dispersion medium is also liquid here. This is really interesting and important also. Here the dispersion medium and the dispersed phase both are liquid, and this type of colloid is called emulsion. Example is milk, face cream, etc. So what is milk? So milk is actually a type of colloid. Basically it's called emulsion, where the fat is the dispersed phase and the water is the dispersion medium. Okay? Next is our liquid dispersed in gas. Means dispersed phase is liquid but the dispersion medium is gas, and this type of colloid is known as aerosol. For example fog, cloud. तो क्या होते हैं यहाँ पे लिक्विड जो होते हैं वो गैस में डिस्पर्स हो जाते हैं. नेक्स्ट है हमारा सेवन टाइप दैट इज गैस डिस्पर्स इन सॉलिड. मींस सॉलिड डिस्पर्शन मीडियम में ज्यादा अमाउंट में होगा और वहां पर डिस्पर्स क्या हो जाएगा? गैस. एग्जांपल है सॉलिड फोम. एग्जांपल pumice stone, foam, etc. And last one is gas dispersed in liquid. Gas dispersed in liquid. Example is simply leather means soap leather, foam, and this type of colloid is simply called foam. And the last one जो कि ऐसा है नहीं, लास्ट तो हो चुका है. नाइन्थ वन जो कि नहीं होता, क्या नहीं होता? यू कैन सी हियर सॉलिड, लिक्विड, गैस. तो गैस dispersed in gas means dispersed phase and dispersed in medium both are gas. ऐसा colloid possible नहीं है ना? Gas dispersed in gas is not possible. Why it is not possible, students? Because gases are infinitely mixable to each other. एक दूसरे में पूरी तरह से गैस जो है वो मिक्स हो सकते हैं, क्योंकि उसमें तो फोर्स ऑफ अट्रैक्शन होता ही नहीं है, नेग्लिजिबल फोर्स ऑफ अट्रैक्शन. इसलिए गैस और गैस का कोलोइड्स फॉर्मेशन पॉसिबल नहीं है. तो ये हमारे 8 टाइप ऑफ कोलोइड्स हैं ऑन द बेसिस ऑफ द स्टेट, जिसे तुम्हें याद रखना है. इसमें इमल्शन थोड़ा ज्यादा इंपॉर्टेंट है. नाउ नेक्स्ट इज प्रॉपर्टीज ऑफ कोलोइड्स. द फर्स्ट प्रॉपर्टी ऑफ कोलोइड इज दैट इट इज हेटेरोजेनस. Heterogeneous means yes, that their components are not mixed together uniformly. So as you can see here, the first property is about its nature. So nature of colloid is what? It is heterogeneous. The second property of colloid is about the size of the particles. As we have already discussed that the size of particles in the colloids, they are ranges between 1 nanometer to 1000 nanometer. And 1 nanometer is equal to 10 to the power minus 9 meter. The third property is about the separation, that the components of colloid, they cannot be separated by the process of filtration. By using filter paper, students, you cannot separate the colloids. You should use a special techniques that is called centrifugation. Centrifugation, जो कि हम लोग आगे पढ़ेंगे. Next is about the stability. क्या colloids stable होते हैं? Yes, colloids are quite stable. अगर नहीं स्टेबल हैं तो हम लोग उसमें स्टेबलाइजर्स आते हैं जो कि ऐड करते हैं उसे स्टेबल करने के लिए. बट if you will leave the colloid undisturbed for some time, so colloids they will not get settled down at the bottom, and by this we can say that it is quite stable. You cannot use the process of sedimentation and decantation here. Next is the Brownian motion. Robert Brown, he was a scientist, Robert Brown. What he observed in a microscope, he observed that the particles of the colloids or colloidal solution, they are showing random zigzag motion, and this random zigzag motion of the particles of the colloid is known as Brownian motion, discovered by Robert Brown. Next is coagulation. What is coagulation, students? Let's talk about it. So when the colloids are being when colloids में हम लोग क्या करते हैं, कुछ ऐड करते हैं. तो क्या ऐड कर सकते हैं हम लोग यहाँ पर, जैसे कुछ इलेक्ट्रोलाइट ऐड करेंगे हम लोग, तो वहां पे क्या होगा, प्रेसिपिटेशन ऑफ कोलॉइड हो जाएगा. द प्रेसिपिटेशन ऑफ कोलॉइड ऑन एडिशन ऑफ सर्टेन इलेक्ट्रोलाइट्स, so this is called coagulation. जैसे मिल्क लेते हैं, दूध लेते हैं, मिल्क में हम लोग क्या करते हैं, कुछ ऐड करते हैं हम लोग, जैसे टार्ट्रिक एसिड, साइट्रिक एसिड, तो क्या हो जाएगा, उसके कंपोनेंट्स अलग हो जाएंगे. ठीक है, इसको कहते हैं प्रेसिपिटेशन ऑफ कोलॉइड, या इसको हम लोग कहते हैं coagulation of colloid. The next property of colloidal solution is Tyndall effect. So let's see what is Tyndall effect. So actually when a beam of light is allowed to pass through a colloidal solution, so the path becomes visible. Actually the colloidal particles, they are big enough, they scatters the beam of light, and the beam of light acquires a conical path which becomes visible, and this is called Tyndall effect. And this Tyndall effect is not shown by the solutions. When you will take sugar and water mixed together, and if you are allowed to pass a beam of light through it, then the beam of light will not acquire any conical path and it will not become visible. So Tyndall effect is not shown by the solution, but in the colloids this Tyndall effect is shown. Why? Because the colloidal particles are big enough to scatter the beam of light. What is the reason of Tyndall effect? Do you know that? Yes, the reason is the scattering of light. The scattering of light is the reason behind the Tyndall effect, and this was first shown by the scientist called Tyndall, Tyndall, Tyndall. So you can see here, there is a beam of light passing through a colloidal solution. It is visible here. So I have written here, beam of light becomes visible inside a colloidal solution. And the last property of the colloids is electrophoresis. Actually, some colloidal particles, they are made up of charged particles. They are charged particles, positive charge, negatively charged. So when we apply the electric field on this colloidal solution, so what will happen, the charged particles, they move towards the respective electrodes. They move towards the respective plates. And this movement of the charged particles of the colloid towards the respective plates is known as electrophoresis. As you can see here, I have taken this U-shaped tube, and I have taken, this is as anode connected to the positive terminal of the battery, this is cathode connected to the negative terminal of the battery. And you can see here, on applying the electric field, the negatively charged particles, they are moving towards anode, and the positively charged particles, they are moving towards cathode. So these were the properties of colloidal solution. Now we will meet in the next part of the video, which will be on the topic is matter Rondos pure, part 6. There we will discuss about suspension and also about some basic separation techniques. So if you have understood, then don't forget to like and subscribe.